for me.
x. So in this question, we have given an integer x. So what we have to do is that we have to return the square root of that value. But the catch is that so we have to return it rounded down to the nearest integer if that's not the perfect one. So and also the second condition is that we have to return the integer that should not be negative, that is non-negative, and you must not use any built-in functions. So like these functions we can't use. So to solve this one, so suppose we have this 4, right? So the square root of that would be 2, right? So the intuition is that, so suppose this 2, if we backtrack it, so like if we multiply 2 with 2, we'll get 4, right? So this is the idea that we will use, that suppose we have 9, so this square root of 9 would be 3. So if we write 3 into 3, that would give us 9, right? So these are the two things that we will keep in mind before solving this question. So for example, the next thing we have is 8. The square root of 8 would be around 2 point something. So we don't have to take the next part of the decimal. So we just have to take the round of the number, that would be 2, right? So moving ahead now. So for the brute force approach, we will be thinking it something like, so we have this value 4. So for this example, right? So we have to check for every number from 1 to 4. I know that it won't be till 4, but still. So suppose we will take this example. So 1, 2, 3, 4, right? So we will start with 1 for the brute force approach. So we will run a loop from like 1 to the last element, that is 4. So for each element, we will multiply it by itself. That 1 into 1 would be 1. Then we will check, okay, so if 1 is equal to 4, no, okay, move ahead. But we will store this value in like, or the previous value here, so that suppose uh, the value, suppose this value is 9, or we have to get the value 8. So that will not satisfy the condition, that would be greater. So that way we can get the value. We will get back to that in our next example. So let's focus on this one. So next one we have 2 cross 2 would be 4. So this 4, we have the value 4 equals to 4. So this satisfies the condition, and then we will get out of the loop, we'll break it, and we will get the answer as 2. So now getting back to this problem, that is 1 to 8, right? So we have to get the value of square root of 8. So we will start with 1, the same thing. It will not be equal to 8, right? Next, we will move on to 2. 2 cross 2 would be 4, right? 4 is not equal to 8, but we will store it in our variable or array, whatever you like. I think variable would be fine. Next, we will go to 3. 3 cross 3 is 9, which is greater than 8. What we will do now, we will break out of the loop. Why? Because all the values that are ahead of this 3 would give us the value greater than 8 only. So that way we will break out. So if you can now think about the logic, that is pretty straightforward. So suppose the value we will take as the value is greater than, no, less than. Yeah, got it. So if the value is less than or greater than equal to 8, the suppose we can take it as the target, right? Then what we will do, we will just store the value like previous or the result, whatever you like. So in the previous, we will add the value for the parent index. And if the value is else part, we will break out of the loop. Then we will simply return the value of which one? Previous one, because we are storing the values in previous. This is the brute force approach that will work, but it can be of, I think, linear time in the worst case, but I think almost n by 2-ish kind of a thing. So that would be around that. So, but the better approach would be to use a binary search in that. So how can we use that? I will tell you about that. Now for the binary search. So for the binary search, we simply need two things. That is the left index, the right index, right? So for now, we have the left one as 1. The right one would be the 4 one. Okay. As we know that for the binary search, we have to find the middle value, m. So m would be L plus R divided by 2, right? So in this case, it would be 5 by 2 would be 4. No, it would be 2. Why? Because we will take the floor value. So 4 plus 1, 5. 5 would be equal to 4, kind of, right? So 4 divided by 2 would be, or 5 divided by 2 would be 2 point something, 2.5. Now we have the value mid with us. So mid would be 2. So mid is here. So we will check the condition. So if the condition would be that our square root or the square value, you that we will be squaring each value. So the square would be mid into mid, right? Then we will check, okay, if square this value is equal to which value? The n. The n that we have in the question, this, right? Or we can say x, sorry for that, is equal to x, right? So what we will do? We will simply return the answer, right? That is the answer for us. That is the value of mid, right? We will be returning mid. Okay. If that's not the case, then we have another condition of L if, right? What if our square is greater than x? In that case, what will happen? Let's see. In this case, we don't have any value with that. So we will save this condition for this one. So let's go to the else part, that our value is equal to for now. So we will just simply go with that. So I'll just explain this one first. So let's run for this one. So you know that we will get the value for 2. So we will simply return the value as 2 in our answer. So let's go to this one. So our L would be 1, R would be 8, M would be 8 plus 1 would be 9. 9 by 2 would give us 4, right? So our value is 4. So let's check if 4 into 4 is equals to 16. So mid into mid, 4 into 4 is 16. So is 16 greater than x? Yes, it is. So what we will do, what does it means that our value is greater than, right? So we have to take the less one. We have to take something that will give us less than 16. So we have to move our pointer to this side of the array. That's understood, right? So to move this side, we have to do what? We have to move the value to of r, sorry, of r to mid minus 1, right? Why? Because this one, we already know that this one will not give us the answer. So our right value is 4 minus 1, 3 now, right? Now, let's see. So 1 plus 3 would be 4, and 4 by 2 would be 2. Now the value is 2. Okay, let's move ahead. So let's check again. This 2 into 2 would give us 4, right? So let's check if 4 is equals to 8. No. Let's get into the else if condition. So 4 is greater than 8. No, that's not a condition. So we'll go to the else part. Else means it is less than the value, right? So we need something that will give us greater than 4 and less than 8, right? So in the else part, we will change the value for our left pointer to mid plus 1, right? Because we need to go now this way, the right direction. Okay. Now our pointer would be which one? Mid plus 1, right? So mid was 2, then 2 plus 1 would be 3. Now we have both the pointers pointing to 3. Let's check again. 3 plus 3 by 2 would give us only 3. So our mid would be equal to 3, right? 3 into 3 is equals to 9. Equals to no, greater than x? Yes, definitely. So we will go right is equals to mid minus 1. So we will take mid minus 1. Mid is 3, so we will go as 2. So as you know about the binary search, so we will not take the value or get out of the loop if we have the values of the condition where L should be less than or equal to right. Now the right has surpassed the value of L. So it is pointing here. So in this condition, we will get out of the loop. Now, what is the answer? So the answer was something less than 9, right? So that value was 4. So the last value that was given to us was 4. In this case, it is the right value. So the answer would be usually for the binary search template, we return the value as left. In this case, our left is 3, so we have to return the value that is less than 1, right? For all the cases because it is one indexed. So that way we will simply return L minus 1 as a result. So I'll just quickly show you the code. That way you will understand clearly. Let's divide the code. So we will simply use binary search template for that. So in binary search we have two things. We are gonna iterate from left till right is less than equal to left. Now we will find the value of mid. That can be right 2, or we can use another one also, like mid is equals to left plus 2, save like memory leak and stuff like that. You can simply use this one also. Whatever you like, you can use that. So now coming to the conditions part. So the condition was, we will be taking the square of each value. So the value would be mid into mid. So if our square value is equals to x, that means we got the answer. We will simply return the value of mid. Else, if the square value is greater than value of x, it means that we have come ahead of our answer. So we have to get to the left side of ours. Uh, so we have to just simply change the value of r to mid minus 1. That way we will go to the left side of it. Or else if the value is less, so we have to go to the right side, then we will be just using the value of mid plus 1. So just remember that if we have to go right, you have to change the value of L. For going left, change the value of R. Okay. So I think this is the all the thing conditions. Now we will simply return the value of L minus 1 in the worst case. So let's run the solution. See if we have any typos. So I think, yeah, this is a pretty efficient solution. So I think the time for the time complexity would be for binary search is basically of log n. Yeah, I think this must be the solution for that. So thank everyone for listening to me. Thank you everyone. So we'll see you in the next video.